year was 1946. World War II had just ended. The Raytheon Corporation needed to shift its efforts from fulfilling military contracts to the civilian front. They had already performed many experiments with magnetrons, radar tubes that generate microwave radiation. Excuse me. One day, Raytheon engineer Percy Spencer happened to walk by a row of these tubes while they were in operation. He also happened to have a bar of chocolate in his pocket. When he took it out, he noticed that it had melted. Curious, he placed some popcorn kernels near these tubes. He switched the magnetron on, and a few moments later, the popcorn popped. Knowing that he was onto something, Spencer exposed a raw egg to these waves. It exploded and showered unsuspecting onlookers with egg on their faces. From these humble experiments, the idea of cooking food with microwaves was born.
Now, what are microwaves? A microwave is a form of electromagnetic radiation, such as visible light, X-rays, etc. It's just a form of energy that propagates in space at the speed of light in the form of an oscillating electromagnetic field. Now, what is an oscillating electromagnetic field? It's just a wave whose amplitude is changing over time. Now, why does water absorb microwave radiation? To answer that question, we have to look at the water molecule. One special thing about the water molecule is that oxygen is a more electronegative atom than hydrogen, which means that the electrons that form this covalent bond are not equally shared. They are pulled towards the side of the oxygen. That makes these covalent bonds polar covalent bonds, and they create a molecule in which the electrons are not evenly distributed. The oxygen that has a higher electron density is going to carry a partial negative charge density, while the hydrogens are going to be left with a partial positive charge density. Let's look at what happens when we put a water molecule in an electric field. Let's say we create an electric field by having two electrodes, one with a negative charge and the other with the positive charge that creates an electric field. If water is put inside this field, water will orient itself such as it will point the oxygen with the negative charge density towards the positive side of the field and the hydrogens with the positive charge density towards the negative side of the field. If water is exposed to a wave like this, water will have to orient itself according to the cycle of the wave. In microwaves, this oscillation happens about 2 billion times per second, which means that water molecule exposed to microwave radiation will force to orient itself many times per second. Here we have a very useful simulation that shows how microwave radiation interacts with water molecules. We can see that the oscillating electromagnetic field excites the rotation of the water molecules. Those water molecules collide with their neighbors and turn that rotational energy into translational energy or motion. And that is thermal energy, and we can see how the temperature of the system goes up. We're going to do a very simple demonstration to show that what heats up is the water in food. We're going to place a piece of dry paper into the microwave and a piece of wet paper into the microwave. First, we need to measure the temperature of these samples, and we're going to use this infrared thermometer. So we measure the temperature of the dry paper. As we can see, is 74 degrees Fahrenheit. Now we're going to place it into the microwave for a few seconds. And we're going to measure its final temperature. As we can see, the temperature increased a few degrees because the paper trapped some moisture from the air. But let's do the same experiment on the wet piece of paper. We measure its initial temperature, which is 56 degrees Fahrenheit, and we're going to place it into the microwave for exactly the same time. When we measure the final temperature of the wet paper, we can see that the temperature raised up to 127 degrees Fahrenheit. That's because the water content of the wet paper is much higher than the water content of the dry paper.
The next time you reheat those leftovers in your microwave, we can't guarantee that you're going to get a great meal. But at least you'll know the physics and chemistry behind how your food is cooked.